Hello, let's go again. Today we are solving this last question of binary search. We are given an array with unique elements of stalls array, which denotes the position of stalls. We are also given an integer k which denotes the number of aggressive cows. Task is to assign stalls to k cows such that the minimum distance between any two of them is the maximum possible. Distance between cows is maximum. So position of stalls is one stall is at 1, another is at 2, 4, 8 and 9. We have 3 cows. First cow can be placed at stall 0, so वो 1 पे आ गई. Second cow comes stall 2 में 4 पे आ गई. Third cow can be placed at stall 3. Minimum distance between cows in this case is 3, which is the largest number possible. Let's try to think about this. एक stall 1 पे, 2 पे, 4 पे, 8 पे, 9 पे है. सबसे और मुझे 3 काउंट्स प्लेस करने हैं. Such that the minimum distance is the maximum possible. सारे काउंट के बीच में जो डिस्टेंस में सबसे मिनिमम है वो सबसे ज़्यादा होना चाहिए. इसको बढ़ाना है. दूसरा एग्जांपल है 1 2 5 7 और 10. इसमें 1 पे होगा, 10 पे होगा और 5 पे होगा, तो 4 और 5 तो 5. Three. यहाँ रखें तो डिफरेंस कितना है, 3 है और 5 है. यहाँ रखें तो 7 है. Distance is maximum. Next is 2, 3, 7, 11, 12, 26. Be right back. back. 2 पे रखेंगे, 26 पे रखेंगे, 3 और रखेंगे। मिनिमम डिस्टेंस जो है अपनी मनी पीपल इवनली स्प्रेड रखना है। 3 से लेके 25 तक बीच में कौन सा एलिमेंट आता है? 14। 3 और रखेंगे। I don't know कैसे सॉल्व होगा।
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist. Now this is the part of the ongoing Strivers A to Z DSA course. In case you are for the first time here and you haven't checked it out yet, there's a link in the description. You can definitely check it out because it is something extremely special. So today's problem will be aggressive cows. But before moving on to the problem, I have covered up binary search on 1D arrays where we did binary search on sorted arrays, rotated sorted arrays, and similar to that. And then we moved on to binary search on answers where most of the problems were find the minimum of something or find the maximum of something. It had just one term, find min or find max. So the problem that we are going to solve today will be aggressive cows. But before moving on to that, I've covered up binary search on 1D arrays where we did all the problems on sorted arrays, rotated sorted arrays, right? After that, we moved to binary search on answers where we did all the problems where we had to figure out find min or find max. Now we will be moving to the other pattern of binary search on answers where we'll be asked to find min of max or max of min. So you'll be doing around 4 to 5 problem on this particular pattern so that this particular pattern sticks to your head. And the first problem on that pattern is aggressive cows. So what does the problem state? It states that you'll be given an array which does consist of n stalls. Now each of the stall coordinates is given to you. The first stall is at the coordinate 0, the next one is at coordinate 3, the next one at coordinate 4, the next one at coordinate 7, the next one at coordinate 10, and the next one at coordinate 9. Your task is to place 4 cows. If you take one
0, 3, 4, 7, 9, 10. First is at 0 and 10. 10 and 5 are. मुझे कितनी कॉल दो और कॉल रखना है। वन से लेके 9 तक टू से 1 से लेके 3 मैक्सिमाइज नहीं कर रहा है।
cow, that one cow can go to either of any of the stalls. Any of the stalls it can go to. Your task is to place 4 cows in such a way that the minimum distance between any of the 2 cows, very important, the minimum distance between any of the 2 cows is the maximum. Might be confusing, but it is of this pattern. If you carefully see, minimum and then maximum, it is of that pattern. Minimum distance between any 2 cows is the maximum possible, and you have to tell me that minimum distance. It's confusing for the first time, but when you understand the question, you'll understand it in a much better way. So basically what it states is, these are the stalls given. If I have to maybe write the stalls in the correct order, the first stall is at 0, 3, and then 4, then 7, and then 9, and then 10. Just I've written down them in the sorted order. If I tell you, can you place 4 cows? It'll be like, okay, cow 1, cow 2, cow 3, cow 4. This is one of the ways in which you can place cows, right? If I ask you, what is the distance between any of the 2 cows? It'll be like, the distance between them is 3, the distance between them is 1, distance between them is 3, and maybe the distance between them and them is 4, and maybe the distance between them and them is 4. So what is the minimum distance among all the cows? Any 2 cows. You can take C1, C3, C1, C4, C2, C3, any combination. What is the minimum? Can I say the minimum is 1? And that will always be between consecutive cows. Like if you just figure out 3, if you just figure out 1, if you just figure out 3, you don't need the distance between these two because you're looking for the minimum. And the minimum will always happen to be between consecutive stalls. The minimum will always happen to be between consecutive stalls. That is the reason I sorted the stalls. Got it? So I know that the minimum is between this one. So if I place it like this, I'll get the distance as 1. And that's what they're asking you. What is the minimum distance between any 2 cows? That is what they're asking. What is the minimum distance between any 2 cows? You'll be like, okay, fine. Can I place it something like C1, C2, maybe C3, and maybe C4? I can. Even if you place it like this, the distance between this is 4, the distance between this is 5, the distance between this is 1. You can take this as well, you can take this as well, doesn't matter. What's the minimum? That's 1. Still keeping it as 1. Still keeping it as 1. Can I place it something like maybe a C1 here, maybe a C2 here, maybe a C3 here, maybe a C4 here, maybe. And then if I figure out the distance between this is 4, between this is 3, and between this is 3. What is the minimum between any of the 2 cows? You can take C2, C4 as well. What's the minimum? 4, 3, 3. What's the minimum? 3. So you can place the 4 cows in any configuration you like. But the core is figure out the minimum distance between any of the 2 cows in that configuration. And over here it is 3. So I write it. And the task is saying you have to place it in such a way that this minimum distance is maximum. This minimum distance is maximum. So if I have placed in this configuration, the distance that I'm getting is 1. If I place it in this configuration, the distance that I'm getting is 1. If I place it in this configuration, the distance that I'm getting is 3. Which one will you prefer? If you're looking for max, I prefer this because in this configuration, the minimum is very big, So they are kind of at a distance. So I can take this configuration and this will be my answer. You can try out other configurations as well. You will not be able to manage more than 3. Like you can also try out something like maybe you can place a C1 here and you will say this. And the question is clearly stating there are 4 cows. You cannot get away by putting just 2 cows. You have to put 4 cows, exactly 4 cows, not more, not less, exactly 4 cows. In placing 4 cows, whatever minimum you get, that is what you consider. So this is not a valid configuration. This is not a valid configuration. So you can try out all the valid configurations and the minimum distance that you see, whatever you get between any of the 2 cows, you have to maximize that value. So what is the first thing that we notice? Since we require minimum distance between 2 cows, we just need the consecutive stall distances. There's no point in computing the farther stall distances because that will be big. I need min. So just computing the consecutive stall distances will make it work. The first thing that you'll do is this array will be non-sorted. The stalls are in non-sorted order. Just go ahead and say, can you please sort yourself? Can you please sort yourself? Because if I can place the cows, and then I can easily compute the consecutive. Can I say, maybe I can try out with 1. Let's try out with 1 and see if that is possible. I'll try to keep a minimum distance of 1. I will not place cows before 1 distance. Okay. What is the ideal scenario? Where should you place your first cow? You will be like, Stripe, I can place it here, 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 or I can either place it here. In either of the stalls, the cow 1 can go. But what is the ideal scenario? Where should you put it? You want to put 4 cows. You want to put 4 cows. So like greedily, you will try to take the first place and then look for the distance increase. There's no point in putting it here because if you put it here, you'll not be able to place 4 cows. So the faster you put, the better it is for you because there is no cow before it. So there is no need to think of the distance. So that is why the ideal scenario will be to put the first cow at the first stall, which is whatever index is given to you. What's the next? I need to put the cow 2 and I need to make sure that the distance is 1. Can I put a cow to here? I can, because the distance is 3. I'm trying to keep a minimum distance of 1. I can. So let's put a cow 2. Can I put a cow 3 here? I can, because the distance is 1. So I can put a cow 3 over here, right? Can I put a cow 4? I can, because the distance is 3. And I can stop. Yeah, I can go ahead and put cow 6 as well. There is no need. I stop the moment I'm able to put 4 cows. So what I see is, if I'm keeping a minimum distance of 1 also, if I'm keeping a minimum distance of 1 also, the distance is 3, it's 1, it's 3, it's still maintaining a 1. So one can be done. One can be done with this possible configuration. So I'll be like, one can be done. Okay, one can be done. But what am I looking for? I'm looking for max. So let's maybe take 2 and see if it is possible. Let's try. Can C1 be here? Yes. Again, ideally always at the first place, because I want to place more cows. Can I place C2 here? Yes, because the distance will be 3 and I need to maintain a distance of 2. So I can. Okay, let's see. Can I put a C3 here? If I put a C3 here, the distance is 1. But I've been asked to maintain a distance of 2. I have been asked to maintain a minimum distance of 2. So ideally, C3 cannot be put here. Okay. Can a C3 be put here? Yes. Because I need to maintain a distance of 4. Sorry, I need to maintain a distance of 2. And the distance is 4. So possible. Can I put a C4 here? Yes, because the distance is 2. I've been asked to maintain a distance of. So done. Apparently, after putting all the cows, I see that this is 3, this is 4, and this is 2. I'm not violating. I'm making sure that each of the cows is at least having a distance of 2. Perfect. So the minimum distance I get is 2. So I can say 2 is also possible. But what am I looking for? I'm looking for big numbers. So now I'll have to try with 3. Now I'll have to try with 3. Let's try with 3. C1 goes here. Can C2 go here? Yes, because the distance is 3. Can C3 go here? No, because the distance is 1. Can C3 go here? Yes, because the distance is 4. So C3 will go here. Can C4 will go here? No, because the distance is 2. Maintain 3. Can C4 go here? I'll say yes. Why? Because the distance is 3 and that is what I'm requiring for. 4 cows, please. Thereby 3 is also possible. Okay, with 3 also I can place 4 cows. The configurations can be numerous. We need to just keep on making sure that it is possible or not. I'm not looking for configuration and looking for if it is possible or not. Okay, so time to increase the value because I'm looking for max. Let's check if it is possible for 4 or not. So what I'll do is, I will kind of try to put a C1 here. Can I place a C2 here? No, because the distance is 3. Maintain a minimum distance of 4. Nah, not possible. Can I put a C2 here? Yes, because the distance is 4 and I've been asked to maintain a distance of 4. Can I place a C3 here? No, because I've been asked to maintain a distance of. Can I put a C3 here? Yes. So C3 goes here. Can I put a C4 here? No, because the distance is 1. So if I maintain a distance of 4, I'm able to make sure the distance of 4 is maintained, but I'm not able to place all cows. Not possible. Not possible. So what?
So this way we are going linearly. Minimum distance should be 1, minimum distance should be 2 and so on. इसको हम बाइनरी सर्च से कर सकते हैं. डिस्टेंसेस कहाँ से कहाँ तक वेरी करेगा? मतलब 2 काउस के बीच में मिनिमम डिस्टेंस कितना हो सकता है, मैक्सिमम डिस्टेंस कितना हो सकता है? तो मैं निकाल दूंगा ओपन इटरेशन से. Then I will do binary search. Okay. Log of distance कितना है इस पे. Max value minus min value. To n. हर बार में उसको प्लेस में तो करना m.
Now we observing. It's possible till 3 and after 4, do you need to check for 5? The answer is no. Why? Very simple, yaar. Why will you check for 5? Just tell me this. Why will you check for 5? Because if at 4 it was not possible. If at 4 you could not place 4 cows, at distance 5 will never be. At distance 6 will never be. At distance 7 will never be. It's not possible. So I figured this out. That we have to start from 1 and you have to keep on checking till the max value. If I ask you, what is the max possible answer? Now remember one thing, the question clearly states that at minimum the question will always have 2 cows. Like you'll never be given one curve, because if you have one curve, you cannot find distance between two. At a minimum, you'll always have two curves. That is what the question clearly states. If I ask you, what is the maximum distance till which you can go? Just think of test cases. I can think of test cases where the number of curves is two, and the worst, like the farthest configuration can be, which is the minimum minus maximum. This can be the maximum distance possible that I can place some curve. Because whenever you're solving a problem, you cannot check for the value of curve. You can look for the extremist case. There where you're saying the minimum distance of we know can be 1. And the farthest distance can be the max minus min. Again, this can be optimized as well. The range can be optimized as well if you start thinking, but that's not our main criteria. Main criteria is to solve the problem. So we'll try to solve the problem in the least complexity. You can optimize this, but that will not affect the time complexity much. But yeah, I'm sure that if I take this range, the answer will always be between this range. You can also take something like 1 and 10 to the power 9. That's also correct. That's also correct. You can take 1 and 10 to the power 9, and we're sure that the answer will be between them. That is also correct. But yeah, we are very much sure that even if cows are given us 2, this range will make sure that the answer is between them. So we know the range. If I have to write the linear search, can I write it like for I equal to something like maybe 1, and then we can go on till max minus min, and then I plus plus. What do we need to check? Can we place curve? If can we place, and we will pass on the array which has the stalls, just make sure.
Let's see if I am nice. I'll be right back. Can place the cows in this house with the same key. Good exam. This body getting hot. This we don't need. Can place the cows. ऐसा देखा नहीं खूबसूरत कोई जिसमें मूरत कोई इसमें जैसे निगाहों पे जादू कोई मेरे पास I have this stall है. Let's take his example only. 03479. I will place one. I will decide which place to be. First काम इधर place कर दूँगा. Okay. Last cow position. Last cow. Last cow. Next one command store 0. Current minus last cow at is greater than equal to many spaces. Then I can place the cow. Placing the cow is k minus minus. Bacon metallic cake comes 0. That means return true. यहाँ तक आ गया मतलब. What? Bro, what? But think about what you are maximizing. The goal is to maximizing means each time it is true what will happen to your answer. Bro, I'm a stupid. It's not like I'm maximum experiment. It's fine again. Little. Let's think about this. Can I place K cows keeping minimum distance as meat? Yes, I can. तो मेरे से छोटे मुझे पता करने हैं। मुझे क्या मैक्सिमम डिस्टेंस कैन आई प्लेस मेरे को ज़्यादा ही फाइंड आउट करना है ना। I cannot place. तो मुझे पीछे आना है। No, I think this is fine. ये भी करके देख लेते हैं फिर। अब तो ये परेशान से ही कर देते हैं।
Before the this, you just sort the stalls if you know time complexity. We need to figure that out.
टाइम कॉम्प्लेक्सिटी क्या है? आई एम सॉर्टिंग दिस इज ऑफ स्टॉल्स का साइज इज एन काउज आर के ठीक है एन लॉग एन then I am doing this search space order of log of high minus low max 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 difference the max minus min order of max minus log of max minus min and every time I am doing can I place k cows how I am doing it order of log n order of n n नहीं k cows है ना minimum of n comma k still I'll go with n only order of n into order of log of the order of n log max minus min plus order of n log n तो n log n ही होगा n log n max distance n plus k counts order of n log n plus n log max distance
After we have implemented can we please, if we can implement the can we please, it is pretty much done. Let's quickly do the can we please. So I'll have to write a boolean function and it will say can we place cows, and it will take these stalls, it will take the minimum distance that you have to maintain, and it will take the number of cows that you have to place. Can I say initially I can keep the count of cows to be 1 because I know the first cow will always go at the first. Well, that's very check much of from I equal to 1 and you go until the last value of the coordinate in which the last cow thing at least we're maintaining that distance. 4. And place a particular cow here. Imagine the cow to goes, now this is your one, this in, at the end of the day, if the number of cows, rather count of cows, if you're able to place more than the required number of cows, that means you were able to place cows by maintaining statement number of going till max my, that's a big like it's a quarter. We apply binary search, we can, because we have already done similar problems. If you remember, it's not possible, and it will go until 10, which is also not possible. Why 10? Because the maximum that we know as we're looking at 1.5, omit this mid, and what I can do is I can also keep an answer variable as -1. Okay, now what is the mid? The value of mid will be 1 plus 4 by 2, that's 2.5. That's 2 as an integer. Is 2 possible? He says yes, it is possible. And if you remember, if it is possible, you're looking for max, so anything on the left will be small. So what you do is you store the 2. You look, it's not possible. So for a possible answer, hence high will be my answer. Got it? So we just need to return the high. Yes, but knows watching my playlist from the first, he knows the polarity process. And if in case you're watching it for the first time, it's very simple. The low is pointing to, so low will always go to the opposite polarity. Not possible. Yes, you know it. First one, low was at a possible point. High was at a impossible point. In most of the cases. So low will always go to the opposite polarity. Not possible. High will always go to a possible polarity. So which one will be your answer? High is always going to be your answer. I hope that makes sense. So no need to use an extra variable answer. So we don't need to store any particular answer variable. And for anyone who's watching my playlist from the first, he knows the polarity process. And if in case you're watching it for the first time, it's very simple. The low is pointing to like possible case. The high is pointing to non-possible case. Binary search will make sure that it ends up at a not possible place, and this ends up at a possible place. It just changes polarity. Possible goes to non-possible, not possible goes to possible. Since we're looking for a possible answer, hence high will be my answer. Got it? So we just need to return the high. No need of storing any extra variable.
Oh, that is something new.
Answer. Got that? So let's quickly write down the pseudocode. It's going to be super simple. I take the array, I take the number of cows. Yeah, that's it. I say, so what will be the time complexity? Sorting at first, so that's an n log n. Plus, you're doing a binary search, so that's a log base 2, and the range is this. So goes to this, multiplied with I, or you can return the mid, because that is what we have to maintain as a distance. And we say, can we place? We call the internal space nothing, big of it. Sorry, big of 1 is the external space that we're using. So let's quickly get back into the code editor and check out the code. By the way, you can figure out the C++, Java, Python, JavaScript codes. The difference between this is 3. The difference between 2. The moment you get the number of calls that you require, stop. Or after it, if you don't find it, just return false. There's other thing, plus Java, Python, JavaScript codes from the notes in the description, and also you can find out the problem link in the description itself to try it out. So
Arrays dot sort. I'll be right back. Yes, I am back.
Put in the exact same code, and I've just taken the conditional statement inside the for loop. The moment you get the number of calls that you require, stop. Or after it, if you don't find it, just return false. It. You can think and trim down the range more as well, but that's not required because the core of the problem is to solve it. You need to our channel. What are you waiting for? Hit that subscribe button right away. And yes, if you haven't followed me on Instagram, Twitter, and LinkedIn, you can find out all the profile links in the description. Make sure you follow me there as well. And with this, I'll be wrapping up this video.
Thank you for that video. That was helpful. We have marked this as done. What is the next topic? Heap. Oh, okay. Heap implementation. पढ़ते हैं इसको. I think नया topic मैं उससे start करेंगे. Let's close it. This one. Right.